Hey everybody, welcome to my video. I'm going to show you an example on how to find the area in between two curves. So in this particular problem it says find the area bounded by the curves y equals x squared minus 6x plus 9 and y equals x plus 3. And the first thing you need to do is you have to graph. You have to know what these curves look like just so you have a better idea of which function or which curve is on top, and you have a better idea of which curve is on the bottom, and you can have a better idea of which points they intersect. So I graphed it for you already over here on the left, and I used the rectangles to shade in the area that we're trying to find. So if you notice that every single one of these rectangles, the top of the rectangles touch the green curve y equals x plus 3. So that is our top function, since the top of the rectangles they all touch that curve. And if you notice the rectangles, the bottom of them, they all touch the red curve, y equals x squared minus 6x plus 9. So that is our bottom function, since the rectangles, the bottom of them all touch that function. And we have our points, our x values a, and we have our x value b, which are the 2 points in which these two curves intersect, which that is our first step. We need to find these 2 points where the curves intersect. So that's what I'm going to do to start off right away. I need to find where they actually are touching. So in order to find out where they are touching, the only thing you need to do is set the curves equal to each other. So our first curve is x squared minus 6x plus 9. And we need to set that equal to our second curve. So it's equal to x plus 3. Okay, and if you solve this equation for x, we find our two values of x, our two x values that where these two curves intersect. So the first thing I'm going to do to solve this equation is to subtract x and to subtract 3 from both sides and make it all equal to 0. So if I subtract x from both sides and I subtract 3 from both sides, I'm left with x squared minus 7x plus 6, and that all equals 0. And this is a quadratic equation that can be solved pretty easily. This factors into x minus 1 and x minus 6 equals 0. And from this point we know that our x is equal to 1 and x equals 6. So our a is the low x value in which the two curves intersect. So our a is equal to 1. And our b is the high x value in which the two curves intersect. So our b is equal to 6. So now we have all the information we need to find the area using our integral formula. So here in the top right part of the screen I have the integral formula to find the exact area, and that's the integral as a goes to b of the top function minus the bottom function dx. So let's plug everything in. Our a we know is 1. Our b we know is 6. Our top function is the curve where the top of the rectangles are touching. Notice the top of every rectangle is touching the green curve. So the green curve is our top function, which is x plus 3, minus our bottom function, which is the curve in which the bottom of the rectangles are touching, and the bottom of the rectangles, every one of them is touching the red function, which is x squared minus 6x plus 9 dx. So if we add and subtract like terms, this integral can be simplified as negative x squared. We have a positive x minus a negative 6x, which becomes plus 7x. We have a positive 3 minus positive 9, which becomes negative 6 dx. So now we just need to calculate this definite integral to finish the problem. So if we integrate the function, negative x squared becomes negative x cubed over 3, plus 7x becomes plus 7x squared over 2, and minus 6 becomes minus 6x. And this is a definite integral with a upper limit of 6 and a lower limit of 1. So if you don't know how to do definite integrals and you didn't follow the step I just did, if you want, you can go back and watch my video on definite integrals. So now our next step is to plug 6 in for x and plug 1 in for x and subtract them with each other. So the first thing I'm going to do is plug 6 in for x. And you need to subtract this, and now you need to plug 1 in for x. This first set of parentheses simplifies and just becomes 18. And the second set of parentheses simplifies and becomes negative 17 over 6. So the area is equal to 18 minus negative 17 over 6, which is 125 over 6. So this is the exact area in between the curve x plus 3 and the curve x squared minus 6x plus 9. So here are some more videos with some more example problems related to the video you just watched. I really hope you're finding my tutorials helpful. So until my next video, I will see you later.